Hello, everyone. Today, I'm happy to have a young Indian astronomer with us. He's still studying, but is far deeply into his studies. We have with us Abhijeet Anand. Let's listen to him. Over to you, Abhijeet.
Yeah, thank you so much for giving me this opportunity to be part of this show. And I'm really happy to talk about my journey, how I became astronomer, and what I have been doing since last few years, and how can I motivate young people who want to do astronomy. Uh, so so it's I'll just talk about kind of like where did it all start, and then how did I move ahead with my passion of astronomy, and then what kind of people and what kind of resources do we really need to do astronomy, and what's the current status of the fundamental research that's happening in astronomy. So I'll just share a screen, and I'll just present a few things to be just.
Yeah, hang on, so I have to authorize you to do it. So I'll put you on pause
sure.
while I do.
Yeah.
Okay, so Abhijeet has got his presentation ready, and let's listen to him.
So yeah, as my title says, like curiosity and the cosmos, and my journey from kid to astronomer. So just to give a little bit of introduction. So currently I'm a postdoctoral fellow at Lawrence Berkeley National Lab in Berkeley, California. So where did it all start and how it all went and how things are going, I'll just mention about myself. So as I mentioned, currently I'm a postdoc. So I am from Patna, which is the capital city of Bihar. It's a city with lots of history attached to it. Like it used to be the capital city of Mauryan Empire and Gupta Empire. So it has a very rich history attached to it. And so following my high school in Patna, and then I went to Indian Institute of Science, where I joined their like newly introduced course, BSMS in physics that I pursued from 2012 to 2017. So basically, I always wanted to do science. That's why I joined through IIT to IISc, and where I learned a lot of things during 5 years about physics, astrophysics, biology, and a lot of like things. I consider myself to be very fortunate that I was part of this course. And then for a year, I also worked as a junior research fellowship, which is a kind of a research fellowship that's basically given by University Grant Commission or CSIR. So I worked for 1 year in a DST, Department of Science Technology sponsored project at NIAS, which is like National Institute of Advanced Studies. It's a small campus. They basically do fundamental science, and it's situated in the campus of IISc. And then I moved to Max Planck Institute for Astrophysics in Garching, Germany, for my PhD, where I was an IMPRESS fellow, which is like an International Max Planck Research School fellow. And I pursued my PhD in astrophysics from 2018 to 2012. And then I moved to Berkeley Lab in September 2022, where I'm currently pursuing my postdoc. So during my time at IISc, I was very fortunate enough to explore different topics in physics. And that's where my basically, I would say, stint with astronomy started. So in the early summer of 2013, I was very fortunate enough to go to Aryabhatta Research Institute of Observational Sciences. It's an observatory which is managed by Department of Science and Technology of Government of India, and it's situated in Nainital. I was there for 3 months where I did some observation project where I was studying stars, basically. So it was like really very different experience for me, because I got a chance to actually see the big telescope, how it works, and how do people do research in astronomy. So that was, I would say, like the most important moment of my life when I actually decided that I want to do astronomy. But like since IISc is a big institute and they have like so many departments with like different expertise and different research field, I also tried to do a bit of like high energy physics, which is basically a study of like particles that we hear, like electrons, protons, neutrons, all kind of particles. So I tried to study a bit of like particle physics during my summer 2014. And I was like really, I liked that project very much. I learned a lot, but I still, back at the mind, I was more interested in astronomy that I had done like previous year. So finally, after exploring a few things in physics, I moved to Indian Institute of Astrophysics, which is again a institute funded by Department of Science and Technology of Government of India. It's in Bangalore. It's purely a research institute, so they don't have any bachelor's or master's program. So they have mostly PhD programs. So I moved there for my summer project in 2015. And I started working again on stars with some observational data coming from different telescopes all over the world. And then I continued in astronomy. Basically, I finished my bachelor's project in 2016 at IIA in Bangalore. And then I again continued for my master's in IISc, where I finished my master thesis at IISc in astronomy. So this is like some of the memories. I was very lucky that when I graduated, like our chief guest of our convocation was Honorable President of India, Shri Pranab Mukherjee. And this is the group photo that we got with like all the dignitaries. So that was like one of the most memorable memories, memorable times during my ISC. I made a lot of friends. I learned a lot of things in different topics, and I really love that place. So I still miss those days. So before I move on, like to what I did, what I'm doing now, and what kind of science I'm doing, I really want to highlight like some of the setbacks that I had seen during my time because these are very important because they made me a better person, they made me more strong, and they made me to learn a lot of things. And I really feel a lot of people at that age have to go through those kind of setbacks. So it's important to kind of like discuss that how people like they are not alone, and a lot of other people also go through the similar things. So I finished my BSMS in 2017, but I failed to secure any PhD positions abroad. I was mostly applying for PhD positions in US, and unfortunately I didn't get. So I was very disappointed because I thought that, okay, I'm preparing, I'm working hard, I'm getting good scores, but I still didn't get. And I wasn't prepared for that kind of situation. So I also had written all the exams for PhD admissions in India, had got like good ranks. However, I was like so disappointed, and I was like so unsure about myself, and I lacked confidence that I didn't attend any interviews. Of course, like looking back, I realized that mostly I was wrong. It was just a phase of life that many people go. So since I had qualified JRF, so I just joined NIAS Bangalore, as I mentioned, where I worked on my MS thesis paper. So I had submitted my thesis, and I was also writing my first research paper during that time. And then I also was preparing for PhD application. And then this was a project that was mostly related to neuroscience, which was very different for me. And I was doing mostly astrophysics. But it gave me like a really different perspective of kind of like doing science and research. So I was very fortunate to do some work there. And really, I got a lot of support from my family and some of my very close friends. And I think that's the most important thing that people can think of. And finally, I got a PhD offer from Max Planck in February 2018 and joined in September 18. I was also very happy because I published my first ever research paper, which was a huge milestone for me during that time, given that like all the setbacks that were happening.
So it took 1 year. It took 1 year to bounce back.
Yes, yeah,
Huh?
exactly.
1 year.
Right.
Because
Yeah,
Max
exactly.
Planck is how, one of the top in the world, or what is it?
Yeah. So it's one of the topmost place for doing astronomy.
Yeah.
They have a very strong astronomy community, and Garching is a small suburban near Munich, which is a kind of a center for astronomy in Europe. So they have like European Southern Observatory, which is kind of a central observatory of all the European countries. So they manage telescopes in Chile mostly. So it's a very, I would say, diverse community doing lots of things in astronomy. So I was like really, really I would say happy that I had got this position, because to be honest, I had never thought that I would get such a position given my previous application season. So it was really, really a big milestone for me and really a big relief
So
for me.
what changed? What changed? Why did they
Yeah.
suddenly accept?
Yeah, so one thing that I realized that perhaps when I was writing my applications during my master's, I was more focused on that, like, okay, my GRE is good, my TOEFL is good, and perhaps I didn't focus a lot on SOP and research statement, and also on my recommendations. So I realized that like these two things are like very important, because GRE and TOEFL is more of kind of a qualifying that, okay, you get certain score and then you're good enough kind of thing.
Yeah.
But the most important part is like your research statement and also like recommendations. So I had done projects, but I didn't have the, I would say, like the recommendations, like as much as that is required for a given position. So perhaps, and since I was also in the beginning of some of my projects, so perhaps I hadn't done enough thing at that time when I was applying. So perhaps a recommendation wasn't like, I would say, as stellar as I really wanted to be.
Okay.
And then statement of purpose, I really worked hard, because now I had more results to actually present, and I also had more courage to show that, okay, I've done a lot of things, and this is the things that I have learned. So I would say these two things I definitely improved. A lot of support from people around me.
Okay, wonderful. So basically, having good GRE, etc., is just you into the short list, but it's not.
Exactly.
You need to have
Because
more to get in.
So I think like, because like I also know people with like, okay, a lot of people will consider that their GRE score was like not very good, but still they got a very good position because perhaps they wrote a very nice research statement and they got like really good recommendation letters. So
Fine.
those two things are very important.
All right, good. Let's go ahead.
Yeah, so just to summarize, like, so of course, like we all know, this life is incomplete without setbacks. So there will be setbacks, bad times, and we will feel completely lost and hollow from inside. But trust me, most of the times we are wrong about ourselves. There will be people to back us, and there will be lots of opportunities waiting for us. It's just sometimes things take time, and we feel really kind of like we feel like we're in hurry to actually get something. So one of my school teachers used to say that kind of we are walking on a circle. Everyone may start at different positions, but we will all cross each other one day. So keep moving forward, trust in your journey, and remember that setbacks are just stepping stones to success. So it's just like bad times, they come and they will go. So and always try to maintain a good health and try to have like good relationship with people around you. So that's always going to be very helpful. So now I'll just talk about like what I am doing, some of the
Before you
exciting
go
science.
there, I just want you to tell us a little bit about the difference in the academic institutions, top institutions in India, and Max Planck and LBL. How do you talk about them?
Yeah, so I'd say like, so in terms of astronomy, so there are like few institutes in India which are really good in astronomy. Yeah, so like so one example is like Inter-University Center for Astronomy and Astrophysics, known as IUCA. It's in Pune. It's basically independent institute, but under the management of University of Pune, I guess. So it's a very good institute started by Professor Jayant Narlikar, who is kind of like one of the one of the giants in field
Yes,
of
of course.
astronomy.
Yes.
Yeah. So this was kind of like founded by him. So it's very amazing institute doing lots of amazing things. And then another institute is TIFR, which is Tata Institute for Fundamental Research in Mumbai, which is again a great place to do astronomy. So it's just that like the things that I wanted to do at that point of time, I was like mostly interested in like doing some galaxies and doing lots of observational projects. And at that time, I didn't find like a lot of people doing those things at those places. So that was one reason that like I really wanted to go out abroad, and Max Planck was one of the institute which I found that they have like all the resources. They were part of like big projects which I really wanted to be part of, and they had access to the bigger telescopes. So I really wanted to be part of like. So this is one big, I would say, difference as of now, and it's mostly coming because of like different countries have like a very different policies in terms of like spending, how much funding is going in science and technology and R&D. And given like US or Germany, they have been leader in many big projects. So they have been part of like really big projects, which are kind of a multinational project. And unfortunately, India is not part of some of those projects. I would mention as I'll move ahead, like what are those projects, which I think that it will be really great if India can also become part of those projects. Given that like it's a global thing nowadays, like, okay, people are not doing things like sitting in their room and doing things completely alone. It's a very global thing. People come together, bring different expertise, perspective, and then it's also easier in terms of like funding for other people. Because then like rich countries can put more money, and then countries which are not putting a lot of money, they can join there and bring their expertise, and then they will learn a lot. So that was like one thing which I find very different. So like Max Planck, it's a small institute, very focused institute. So lots of astronomy, so all the astronomy people. And then since they are part of like very big projects all over the world, it provides you those kind of access, which is not very easy to get if you're in India. And same thing goes with LBL. LBL is kind of LBL is like a Department of Energy lab. So they have been part of like very big projects which are funded by US. So you also get a chance to be part of those projects, and you can work, and it gives you that kind of networking which you will need when you really want to collaborate on some big problems and big questions, which sometimes you might miss in India because you don't have kind of that kind of access to those resources.
Okay,
So,
I get
yeah,
it.
so,
All right, I get it. Let's talk. Let's shift to
sure.
science. Let's shift to
Sure.
science.
So I'm pretty sure that you had seen this image few months back by Anshuman, I guess. Yeah.
Yes.
So so Anshuman is my junior at Max
Yeah.
Planck. So when I was in my third year, he joined there. So I know him very well. So so this is like just the history of universe basically. So we all know basically we at least like, okay, in astronomy, like, okay, people it's a like hypothesis that like universe started with Big Bang, kind of a very big explosion, and then universe started kind of expanding. And as it expanded, universe like started cooling, and then there were like a very long time when there were like no structures basically, and that's called dark ages. And then when universe was expanding, it was also becoming cooler and cooler. And as it became cooler, like basically the particles come together and they combine and then formed like atoms and molecules and started forming first structures. So like these are like the first structure, like stars or galaxies. And when they formed, they again started kind of like reionizing, means like they started breaking up the atoms and molecules because they were very powerful sources of light, basically photons. So they started kind of breaking up again. That's called the reionization phase. And then universe was like evolving, so lots of new structures were forming, and finally we see lots of galaxies when we see now. So those were like formed as universe expanded. So basically there are like two main fields in astrophysics, I would say. So one is cosmology and one is astronomy. So cosmology is basically that focuses on like how universe was formed. So it's more like a very large scale stuff. And then how it evolves, basically. So that's the idea in cosmology. So it's like a very large scales, like millions and billions of like light years. And they are called cosmologists, basically. And then there are like astronomers, which are who basically study the astronomical objects like this, like galaxies, stars. So all the astronomical objects that we see, basically. So so these are like small scales, like less than million. Of course, like in terms of astronomy, it's a million and billion is kind of like a usual scale, but yeah, you can imagine. And these are basically astronomers. So these are two fields, and then a lot of people just like go around from one to another, depending on like, okay, their interest. And sometimes there's a very strong connection because, okay, what is happening at large scale also impacts what's happening at small scales. So a lot of people are somewhere in between, basically. I consider myself as an astronomer, but now I am working very close with people who work in cosmology. So I would say that, okay, I'm also kind of in some way in the transition phase.
Okay.
Yeah. So so just to let people know, like, how do we study? So basically, there are like it's like same as all other fields. So basically, you have theory, you have observation, and then with now computers, you can also do things on computers, basically. So theory is basically, you start from some first principles, like you start from some assumptions. Okay, this processes may involve this kind of things, and then you create a model, basically, and then you try to kind of like see if your model fits or matches with the observation. So that's the idea behind theory. And observation is more about, okay, I really want to go in sky and observe things, and then I really want to find things, and then I would maybe, and then there will be some theories. Maybe I'll just go and check if my observations match with theory. So basically, you need big telescopes either on ground or in space. So you may have heard James Webb Space Telescope, which is kind of which was launched a few years back. So that's one of the biggest space telescope. Before that, there was like a Hubble Space Telescope that was launched in 1990s, and it has done tremendous job like expanding our knowledge about cosmos. And then we have ground-based telescopes like the Keck Observatory, which is situated in Hawaii, managed by Caltech. And then we have Himalayan Chandra Telescope, which is in Leh, Ladakh. So it's managed by Government of India. So we have few telescopes in India. So and then, of course, with the advent of these big supercomputers nowadays, people can combine this theory and observation and do a lot of numerical work and try to come up with like a computer simulations, and then see if they match with their theory and observations. So these are the three things. And then, people work kind of like interchangeably in these kind of like fields. So I consider myself mostly as an observational astronomer. So I work mostly with telescopes. So so just to give you an example, this is a very nice computer simulation. This comes from Illustrious. It's a big project, kind of like a lot of people from Europe and US came together, and they basically built up a computer simulation of the universe, basically. So here, if you see, basically it's showing that how universe, So basically it's showing that how universe looks on different scales. So if you see here is like 42.5 megaparsec. So we are now in megaparsec scale, basically like the millions of light year scale.
Yeah.
So if you see, so if you see, it looks like spider web, basically.
Yeah.
Universe. Yeah, so you see lots of like, okay, you see some places where you see a lot of dense regions, and then you see some regions which look like a void, right?
Mm-hmm.
So yeah, so on very large scales, if you see universe, then it's not very uniform. It's not that everywhere matter is distributed uniformly. So that's one thing that was very surprising for people. Because initially we all thought that, okay, universe should be like a uniform, like every part we should find galaxies everywhere, but then there were regions we find more galaxies, and there were regions we don't find many galaxies. So this is, and then now as the video moves, you see we are moving to smaller scales.
Yeah.
So now we are like 20 megaparsec, and then we are at like now 10 megaparsec. So you can see now you see lots of smaller structures which you were not able to see initially. So now, and then it will move, and then you will see it keeps moving, and now you are like, so yeah, if you go smaller and smaller, now you started seeing some galaxy.
Right.
So yeah, we zoomed in basically from megaparsec scale to now kiloparsec scales, and now we see, oh, there is a nice galaxy. So that's how universe looks when you go from small scales to big scales. And this is based on computer simulations. Of course, it's not the complete reality because we have to assume lots of things, but still gives us a picture that universe is like really big and really different at different scales. So currently I am part of this very big project, ongoing project. It's called Dark Energy Spectroscopic Instrument. So it's basically a telescope situated on Keat Peak in Arizona. So and it's a multinational project with like 69 participating institutions all over the world. And that's one of the projects that I told, like, India is unfortunately not part of, which we can, of course, maybe in future. So this is like mostly funded by Department of Energy of the US and National Science Foundation. And then there are like some private funding agency as well, like Simons Foundation and Gordon and Betty Moore Foundation. So, and this is the telescope that we use. So this is the dome basically, and then the telescope is inside this dome basically. So, and what is we are doing basically? So the goal is basically to kind of like map the universe. So basically you want to observe galaxies, and you want to see like how universe looks on very large scale. So as I showed on computer, now you really want to see with observational data. So you really want to see with like real galaxies, basically, that, okay, if universe looks that kind of that if universe looks similar as we see in computers. So that I showed, that video was based on computer simulation, but here these figures that I'm showing, this is based on real data basically. So every point is basically a galaxy here. Wow. So you can imagine, like how many. So we are going to observe like 40 million galaxies over 5 years. So this survey is going to run from 2021 to 2026. So we are already in like third year of the survey, and we already have achieved a lot of galaxies. Okay. So here you see here, I'm just showing a very small region close to the center, and this is how universe looks in on big scale. So it's very web, like a spider web kind of like features you see here as well, right? So this is like I was saying that, okay, people using computer simulation, now the real data and kind of like matches very well overall, that, oh, you also see very similar. And this is like reality because these are the real galaxies. So so our goal is basically to create this kind of maps. So this is what this survey is doing. And it's very important to create such maps because that gives you an idea about how universe has evolved over the time. as I showed in my first figure, which I was showing like history of universe. So basically, if you go far in universe, you see different types of objects.
Okay.
And then when you are very close to observer, you see different kinds of objects. So when you go very far, you can see many objects distributed along different, like in different directions very differently. So this is the goal basically. And this is the telescope. As I mentioned, here I am. I was there for my observing schedule. And this is the telescope basically.
Okay.
And yeah, so this is the dome, and then this is the telescope. Inside that dome, it's a 4-meter telescope. So basically mirror size is 4 meters in diameter. So it's a very big telescope. And this is the machinery basically. This is a spectrograph. So basically a spectrograph is a device that basically breaks light into different wavelength components. So so it's like a prism. So you know, when people pass light, you see those rainbow colors, right? So this is like that kind of device. And you can see it's a very complex machinery, and it's kept on like one complete floor, and the telescope is on the other floor. And then there is a communication between telescope and this device. So and the machine is kind of, and this is like, can you see the video?
Yes.
So yeah, so these are like basically, it's a very automated machine, because if you want to observe lots of objects, if you do it by hand, and you're gonna like take like thousands of years to finish, right? So these are very automated machines. So this is the basically focal plane, which is like the focus of the mirror, where you have these robotic arms. So each robot basically kind of like can move like on millimeter scales, okay? And they target, like each robot target one galaxy. So they're like 5,000. So you can imagine like, okay, at any given time, you are pointing on 5,000 objects in the sky. And these are basically connected to optical fibers, which actually take light and then pass it to those spectrographs that I showed.
Right.
So yeah, so this is and see the movement, like you can see this is like a real-time movement. How do they move? So basically the position in the sky.
Yeah.
So and these are like so these are basically our goal is basically to get this kind of spectra, which is called spectra, which is basically you measure like fluxes, which is like intensity of light, but you also want to measure like at what wavelength, not just like total intensity, but at what wavelength. So this is like spectra. And basically you start from this. So this is like a CCD image. So you can't see anything here, but then you do a lot of like work, and then you see, oh, this is a very nice spectrum. So this is how it works. So basically when we want to create this map, as I said, right? So you really want 3 things. You want like, okay, it's like a sphere. So if you want to get a point, you want to see like what is the angle and what is the distance, right?
Yeah.
If you know the angles and you know the distance. So basically when you point, you know the angle, because you know the kind of, okay, this object is here and this is my reference. So I know. You just want to measure the distance. And that is like a hard part in astronomy. Measuring distance is like one of the hardest thing to do in astronomy, because we don't understand like how universe expands. Basically, we don't have very good understanding. So it's very hard to come up with like, what is the exact distance? Okay, when you are on Earth, you know that, okay, 2 point, okay, it's either on a straight line, but in universe, it's very different. So that usually comes from spectra. That's why we take those spectra, because that gives you some idea about like how far is that object. An idea behind that is that like, okay, you have these different galaxies you can see, right? So if the galaxy is far, that light that reaches us is basically red, mostly red. So they're kind of like going towards red. If a galaxy is close, then it's mostly towards blue. So if you see a lot of red light in the spectra, you know that, okay, that object is very far from us. If you see a lot of blue light, then you know that, okay, that object is close to us. That's the idea. So that's how you measure like the distances in astronomy. And then once you have basically angles and distance, you can do this mapping. So you can just map everything on your sphere and then see how things look on very large scales. So that's the idea behind when we say largest 3D map. And I'm very excited to say that actually the Dark Energy Survey is making the largest 3D map of universe ever made on the planet, basically. So this is like the biggest, like, okay. So like whatever, yeah. So the idea is like, so we were doing this kind of survey for very long, like since last 40 years. And all the data accumulated over last 40 years and the data that this experiment accumulated in 1 year was like 3 times more than all the data you had in last 40 years. So you can imagine this is like a really, really exciting thing to do. Here I'm just showing a galaxy now. So there I was showing like universe, right?
Yeah.
Now here you can see how a galaxy forms. So this is again a computer simulation. So you see in the center, you see that something is forming like a disk kind of structure. And here I'm showing like, and you see in the zoomed version how it looks like on very small scales. So you can see that, okay, there are a lot of like material going inward and then they're kind of like moving and they are forming this kind of a structure, disk structure. So, and this is how a galaxy that looks like this forms basically. So this is based on computer simulation. So lots of assumptions. It's not very real, but still kind of give you an idea. Okay, that galaxy. So if you, in the end you see a galaxy has formed that looks very similar to this galaxy, which is a real galaxy.
Okay.
So that's the basically goal of computer simulation, to come up with models and show that, okay, oh, a galaxy is forming and it looks like this and can be seen in observations. So that kind of a feedback from observation to, and then once you see an observation, you can also, oh, you know, we see that kind of galaxy. Can you form that kind of galaxy in your simulation? Then you come up with like a different model, put different physical mechanisms, and then kind of a feedback from simulations to observation, observations to simulation kind of thing. And that's why a lot of people really want to work at the bridge of theory and simulation. So that's the idea. So just to summarize, I am part of this big project, which is making the biggest map of universe. And we want to answer some of the most fundamental questions, basically how universe formed and how universe evolves. That's like the most fundamental thing that we can think of, basically. And of course, there are many ways to contribute towards science exploration, and I am doing it in one way. So there's nothing like a big or small things. Important is like really to make some effort and contribute. And I would like to tell people, like, do many things. It's okay to fail, accept the setbacks and move on. The journey of success is very different for all of us. And yes, take care of your health and relationships. Do not forget them. That's very, very important. So that's my journey, and that's what I have been doing since last few years. And it's going really good, I would say.
Yeah. Okay, great. Can we just get out of the screen share so that we can talk?
Yes, yes.
Okay, well, Abhijeet, congratulations. It's a pleasure to meet a smart young man who says things that people like me can barely keep up with. And, you know, probably tomorrow morning forget.
No,
but I mean, I'm glad that, you know, we have such people. And it's unfortunate that we don't have the resources or the policies to actually get involved in these projects, but it'll come. I hope in some time. We still have ways to go, and I hope it is. China part of it?
Yes.
Yes, that's what bugs me, you know, that, you know, we say we are going to be as good as China. We are the third largest economy in the world, and yet we are not there in terms of where China is. And
yeah, it's like, it's very, I would say, like when I see all these big projects, and then I see like lots of universities from China being part of those projects. And that's how, if you see the Chinese universities in the last few years, they have been like, now they have been ranked like in top 20s now in the world, like becoming kind of like one of the best places to do lots of things. And we still lag in those things. And we just, as you mentioned, we really talk about that. We really want to compete with China, but sometimes it's sometimes I really think that, are we actually competing, or we are really,
we are not.
we are so far now that,
you know, people simply say, oh, these rankings, they don't take account of India and all. So come on, we're doing a project. Here is an international project. You're saying there's so many countries in it, so much money in it, and yet we are not in it.
Yes, exactly.
It's a simple truth that we are not in it. And it's not the only one that we are not in. As you said, there are many that we are not in. And yet we try to shut the eyes to the reality that China is in it. So I'm glad that you validated that. Listen, China is in there, and they have, of course, they have more money. And even if we become the third largest economy in 4-5 years, whenever that is, we won't have the resource. We don't have the infrastructure to participate, because you need the top people from India to join in those conferences. And if you don't have those top people, and if you are not grooming those top people, if you are not saying to people like you, hey, come back and set up something, right? Come back, set it up. You've seen it, you know what it is. Come and set it up here in Pune or Bangalore or Mumbai or wherever. Come and set it up. We'll give you the money. And let's start. And then we can say 5, 7, 10 years. Otherwise, they're saying, oh, eventually we will do it. Oh, yes. It's just when we wish we get it. I say, come on, guys. This is not science. This is not really science. You have to have a solid structure of people, from bachelor's to master's to PhD to postdoc to associate professor. You have to have the whole range. Get into it, because there's a counterpart on the other side.
Exactly.
There's a counterpart on the other side. You can't just say that we produce such good people. Well, yes, you do.
So exactly, I like when I see like the kind of like job applications coming from Chinese places, and like the way kind of like they advertise their positions and the resources they are offering, it's kind of like really luring even for like people from Europe and US. And I have seen like a lot of Americans and Europeans actually going to Chinese universities and being part of their programs.
They're throwing money at it all the time. What they say in the US is to some people, now, why are you applying to NSF every 3 years? We'll give you for 10 years.
Exactly. So it's a very different thought process, I would say. As you mentioned, it's a very different approach.
Okay, so that's fine. Okay. But talk a little bit about the personal side of your accomplishments. And you mentioned the failure and all, but tell us about the successes also. What made you feel so successful? What gave you the success? I mean, Patna is not kind of your launching pad to greatness. But
so I would say, so the thing is, like, one thing was like very, I would say from the very beginning, like my parents were like in that sense very, very supportive of idea that, okay, what you want to do, you can do. Even like I come from Bihar, where like it's very kind of it's a very backward state in terms of economy and development. And a lot of people really crave for like, okay, getting a job just after like finishing your college. You just want to get a job, and preferably a government job, because that's what people really crave. And when you are like young, preparing for, and then most of the people are either preparing for medical or engineering, because that's two things that people think that, okay, once you become these two, then your life is kind of a settled kind of thing. So even in that scenario, even in that society where everybody is doing those things, when I actually said that I really want to do kind of science and I'm not interested in doing engineering or medical, they were really supportive. And to be honest, like they didn't know about ISC, because ISC is not very kind of like as known as like IITs and that kind of brand, right? So it's kind of because IITs, they have all this coaching and everything, like people really crave for IITs. ISC is not like that place. So when I actually kind of like told that, okay, I really want to do science, and I'm really preparing that if I get a position in ISC, because ISC had just started like bachelor's program. So it was started in 2011. So ISC didn't offer any bachelor's program. So I was really fortunate because I was finishing my school during that time, and I came to know about this project, this program. So I was really interested. And my parents were very supportive, even though they didn't know anything that was going to happen. It's a new program, nobody knows the ISC, and everybody okay. And when I kind of like, because ISC was like actually taking students from either through IIT or AIEEE or AIPMT at that time. So kind of like a scenario when I'm like leaving IIT and going to ISC, it was like kind of a, oh, what are you doing? It's kind of a who knows ISC, you're going somewhere in Bangalore, nobody knows what's going to happen, are you
Yeah.
going to get a job and kind of thing. But still I would say like, okay, my parents and my family, they didn't care about those things. They just wanted me that, okay, if you are happy, you know that this place is good for you, then you go ahead and we are with you. So I would say, yeah, so that was like really, really big push for me, that I was fortunate enough that I got a chance to be part of ISC. And when I went to ISC, yeah, as you mentioned, even though like Patna wasn't like a launch pad for me, but ISC really made me a completely different
Look,
person.
once you get in there, it's
Yeah.
different.
So
The world is
yeah,
changed.
so yeah, exactly. So now I meet people from different background. Everybody is like coming either leaving their IIT or
Yeah.
medical colleges. Everybody really want to do science, and then all the senior people there, and you see them. Oh, wow, this is like, oh, this is amazing environment. I really want to do this.
Yeah.
So
That,
that was like a really, I would say, like, yeah. So parental
that is a
support,
launching pad.
basically.
That is a
Yeah,
launching pad.
exactly. Yeah,
That is
exactly. So
surely.
that's
That,
where, yeah, so that's where things changed. And as I said, when I finished my bachelor's and master's and not getting any PhD position that I really thought that I would get, and seeing my colleagues actually getting good positions. So that was also like, I'm still kind of like young and I'm kind of really want to do something and I'm really trying hard and I didn't get a position. So that was like really disappointing that, okay, everybody's moving for their positions. They really are continuing what they want to do. And I'm here stuck because I'm feeling kind of very weak at that time. And as I said, like I was wrong. I could have like joined Indian
right.
places. Maybe I would have started doing. But yeah, I can imagine just like a 22-year-old guy and thinking
Yeah.
about these things, and it feels very kind of like a hollow at that time.
True. True.
But
True.
yeah, even that time, like parents were very, very supportive, and my elder brother and sister, they were really supportive
Okay.
and telling me it's fine, even if you didn't get this year, just prepare hard. Maybe next year you will
Yeah.
find a good
Okay.
place. And this is
All
what
right.
I did.
Okay. Anything else you want to tell us?
So yeah, I would also say that like, yeah, so like we should never forget. So yeah, because science, profession, everything is a lot of things. We actually, it's like half of our time, most of the like, it's a major part of our time is basically go sitting and doing some things for your science or for your work. But like, yeah, we should definitely find hobbies. We should definitely pursue our hobbies. We should definitely find something that brings some kind of like calmness and peace in your life. So like, I really listen to Hindustani classical music, even though I'm not a learned person there, but I listen to Hindustani classical music, and I play flute
Vocal
sometimes.
or instrumental?
So I listen to both vocal and instrumental because I'm interested in classical music. So although like I really want to hear all this like ghazals and ragas and all like big people in classical music. And then I also play flute, amateur flute player. So I started playing flute when I was in college on my own, started learning from YouTube, and I just kind of do practice. I'm not very good, but yeah, it gives me that kind of a thing when I am very kind of like occupied with something and I really need some time, which
Yeah. Yeah.
like a peace time.
Yeah.
So yeah, and so I really like I during COVID I learned a lot. I learned some origami because I was alone in Munich and I
Yeah.
wasn't doing. I was like everything was closed, and so it was
Yeah.
really bad time. So I learned a few things there.
Yeah.
And yes, and with this all the YouTube and like recently chat gpt, I have found many ways that can help me actually. So I'm really, really happy that these technologies have gone
Okay.
so far that actually it has made my life way easier. I'm much more productive now,
Yeah.
and I use them on. So I really want to like tell people, young people, that like There are so many things around us, and it's very easy to get lost. It's just like try to find out some time for yourself apart from your work. Yeah. So that's the message that I would like to give to people. Yes.
Okay, Abhijeet, thank you so much for explaining science so well. And
Thank you.
of course, still don't expect others to understand it.
No. I just wanted to, yeah. So I just wanted to,
because
yeah.
it
I
is
just
a
wanted to.
tough thing to understand.
No, yeah, that's the
And,
thing. I just wanted to make sure. I
yeah,
just wanted to, yeah, like young people when they see
maybe
videos,
they'll
like
get
okay,
it better than I did.
yeah,
I got quite a lot.
no,
Considering,
yeah, it's just like excitement that people
it's
like. Okay,
excitement to
yeah,
understand
exactly. That's the
the
most
most
important
basic.
part.
It's it's the most
Yeah,
basic questions
yeah, exactly.
of life.
Yeah,
Actually,
exactly.
that is what
Yeah,
is what you are answering, the most basic questions of life.
yeah,
And life is not what we think it is. We don't know the
yeah,
answers to
yeah,
these
exactly.
questions. We really,
Yeah,
I don't even
yeah,
have even maybe 50% of the answers, because as you said,
yeah,
we have no clue as to how these galaxies were formed or what happened at all. Okay, let's
yeah,
leave that alone. Thank you
yeah.
so much. Let's end
Thank
it
you
here
so much.
today.
Yeah,
Okay,
yeah.
so
Thank you so much for giving me this opportunity. I'm really, really thankful.
okay, good. So
Yeah,
I'll be back with another young person or an expert soon, or a young
sure.
expert like Abhijeet. Okay, bye everybody.